Now, today, when we graph these linear functions, that's still our main goal of today, is to graph the linear functions on the coordinate plane. That way we can, like we have the last few days, find the slope, the y-intercept, the x-intercepts, and the zeros. But today, I'm not going to be giving you points and slopes and or 2 points like we did last time with all of the digital graphing that we did. This time, I'm going to be giving you the slope and a point from very specific equations. Has anybody ever seen this equation before? Yeah, what's it called? Y equals mx plus b. Well, that's how we say it. But everybody look at their green piece of paper. It is called slope-intercept form. What equation is it on my formula chart?
9.
It's equation number 9, which means it's given to you always. Why do you think that it is called the slope-intercept form equation? What information do you think it gives us if it's called slope-intercept form?
The slope.
The slope and the y-intercept. Specifically, the m. M is still my slope. That's what we've been finding this whole time. So the slope is the m value in y equals mx plus b. And today, and every time we talk about slope in an equation from here until the end of time, you're going to circle the slope. Let me do that one more time. I'm going to be really annoying about this right now. Look at this equation. If I'm circling the slope, what did I circle? Did I circle the x? No. Should you circle the x when I ask you about the slope? Slope is a number, it's a fraction. So do not circle the x along with it. It is just the number m. Okay? The y-intercept is the value b in the equation y equals mx plus b. And let me be annoying here as well. From now until the end of time, if you have a slope-intercept form equation, you're going to put a box around your y-intercept. A box around b. And I'm going to do y-intercepts in blue. So boxes around the b in blue. Now, notice, did I just put this box around the letter? What else did I put my box around?
Plus sign.
The plus sign. I want you to include the sign of that number when you put your box around it, because it's going to help us remember if these are positive or negative values. From that equation, given the slope and the y-intercept, remembering that slope is just my rise over my run, I'm going to be able to hand graph this equation. Let's look at the example they gave us here. It says, graph the equation y equals negative 2x minus 1. We circle the slope. What's the slope? Negative 1/2. So I'm going to say the slope is negative 1 over 2. Should I be going up or down? Down, and always to the right. What's the y-intercept here? Negative 1 or minus 1. That means my graph is going to start or begin at the y-intercept 0, negative 1. That's what all of this information tells me. So if you look at the graph they gave you, isn't that negative 1 where they began graphing? Right here where I put this blue dot? That's the value negative 1. From there, to plot more points, all they did was follow their rise and their run. They went down 1 and over 2, and they plotted another point. Then they went down 1 and over 2, and they plotted another point. Then they went down 1 and right 2, and they plotted one more point. Then this person who graphed this for us on our notes, they took their ruler. They put their ruler down on their paper, and they gave me a nice straight line all the way across the graph, making sure that their endpoints have arrows. I'm going to be picky about that. What should your endpoints have? Arrows. Okay, that's what we're doing today. We are graphing lines, old school style. Can we try one together? Yes. Okay, let's look at example 1. It says f of x equal 2x plus 3. Remember that f of x is just a fancy way to talk about y. So this is really just saying y equals 2x plus 3. Let's go with Will. What should I circle here? What's the slope? Will. 2 voices named Will today. 2. Okay, Will the first voice or Will the second voice. How do I write 2 as a rise over a run? How do I write it as a fraction?
2, 1 over here, and then 3 as a
No, I want just the number 1 as a fraction. I just want the number 2 as a fraction. 2 over 1. Any whole number can be written as that number over 1. Which means, am I going to go up or down? And I'm going to go to the right. There's my rise and my run. That's my movement number. That's what you can think of for m is the movement. And I need to box a number back in my equation. Santos, what am I going to box in this equation? The plus 3. And that tells me that my y-intercept is the value, or the coordinate point 0, comma, negative 3. Whoa, just kidding, positive 3. I don't know what I just meant. That tells me where to begin. We begin with the blue, or the B, and we move with the red. So everybody right now, I want you to plot a nice, good coordinate point on the y-axis at 3. That's the coordinate 0, comma, 3. Then I'm going to use my slope to find more points. We said the slope was 2, which means I'm going to go up how many?
2.
And over how many?
1.
Okay, I'm going to do that pattern repeated across my graph multiple times. So I did up 2 over 1, and I plotted a point. Bless you. Then I'm going to do it again. Up 2 over 1. Then I'm going to do it again. Up 2 over 1. And I'm going to keep going until I have 3 or 4 points, because then I'm going to take my ruler or my straight edge. I'm going to use this protractor because it's smaller for my iPad. And you're going to lay the protractor or the ruler on your paper, line up all of the points, and draw you a nice line across your whole graph ending in arrows.
That's nice.
Voila, we have graphed this function.
I can do that straight.
You have a whole ruler. What do you mean you can't? I forgot you had the ruler. It's got to be precise. We are all about precision when it comes to graphing. So really line up that ruler. What are our questions before I have you try some on your own? Because that's like literally it. Ask it when you think of it. Okay, I'm going to send you off on your own in a second, but I'm going to help you set up number 2. Check out number 2. Let's go with Fatima. What's the slope? Huh? What are we circling? 1 over 2. So everybody write that down. We've circled it. Everybody circles it. And everybody write down 1 over 2. Fatima, am I going to go up 1 or down 1? Up 1. Why up 1 instead of down? Because it's a positive number. Yeah, it's an up number. Very good. Okay, cool. Let's go with... Yeah, Kai, what am I going to box? Negative 4. Making sure I include that negative because that helps me remember that my y-intercept is 0, comma, negative 4. At this point, you have all of the information that you need to be able to graph this function. So go ahead and do it. No, make sure you're not starting at the x value of negative 4. That's not where we're at. We're at a y-intercept, which means we need to cross this graph at the y-axis. Okay, make that note for yourself. That's the y-intercept right there. Don't put it on the x. That's the x-intercept. In the meantime, unless you have another question, I want you to finish this page for me. Do numbers 3 and 4. In fact, I'm going to put the answer key up here in a second just so you can see it. Don't just copy it down. That's not helpful. Actually stop and try to do these problems before you look up. But go ahead and get started on 3 and 4, please. Hopefully you had time to check your work. So you can pause it again and look at these graphs to make sure you understand where all of these are coming from. Where all of these numbers are coming from. But let's look at the back of this page. On the front, we were using slope-intercept form. On the back, what form of an equation are we using? What is this called? What does it say it's called? Point-slope form. What number is point-slope form on your formula chart? 10. Number 10. Why do you think it's called point slope form.
Because they give us a point and a slope.
That's literally exactly right. Mathematicians are so lazy, we name things exactly what they give us. This gives me a slope. It's still m. It also gives me a coordinate point, x, comma, y. But this is a little bit confusing, so stick with me for a second. Still, the slope is the value of m in the equation, and we're still going to circle the m. The point that they give me is x1, comma, y1. The x's are at the back of the equation, and the y's are at the front, which is a little bit backwards, so pay attention. In the example problem here, this should say y minus y1 equal to m times x minus x1, which means that the m that I'm circling is negative 2/3. Everybody circle that number, negative 2/3. That means that my slope, negative 2/3, is it going up or down?
Down.
Down and then right. Very cool. We already know our slope. That part stays the same. Bless you. But the coordinate point that I have, everybody look at this for a second. The coordinate point that this equation tells me is negative 3, comma 5. How is that possible? That it's negative 3, comma 5. So now that we've kind of practiced getting the points, now that we've practiced getting the points out of the equation, we can start graphing these lines. Oh no, it didn't stick. Okay, here we go. In this equation right here, which is the only one I'm doing with you, so make sure you pay attention. What is the slope here?
3. No. Negative 1/3.
Negative 1/3. Oh, I circled that real ugly. Let me try again. Okay, so my slope is negative 1/3, which means am I going up or down? It's negative. We're going down. Okay, the next thing I need, or that information that I know, is a coordinate point. What's the coordinate point given to me?
-0, -2.
Oh, remember, this is an x and a y. Specifically, the x and the y here. So it should be 2, comma, 2, 3. The opposite of what you see. You see negative 2, negative 3. So you tell me 2, 3. So what I do is I use that coordinate point of 2, comma 3. I plot the coordinate point that they gave me, 2, comma 3. Then just like we did a second ago, I'm going to utilize my slope to find more points. Yeah, they are kind of small. Zoom in with your face. You know, you zoom in with your face. What? I'm zooming. Okay, wait, back up. Now we're getting off track. From that coordinate point, I'm going to use my slope to find more points, which means I'm going to count down how many and over how many. And then that's my next coordinate point. I repeat that again. Down, over 3. Until I feel confident that I can draw a straight line between those points. So here I go. I'm putting my ruler down. And I'm going to draw a straight line across the whole graph with arrows at the end. You can draw 3 or 4. 4 would have been fine. 4 would have gone right here. Here, I'll be consistent.
That's where I am.
Right there? Perfect. Let me help you set up number 2, but then you've got the rest of this paper to work on by yourself. Here's number 2, right? What's the slope of the second one? 2. Thank you, Milo, which means that this is going to be the slope 2 over 1. I'm going up and then to the right. What is the coordinate point?
So that'll really just be 2.
0,
0, comma 2.
Remember, the coordinate point is just like we got out of Desmos, x and y. 3, 1. The x's, then the y's, but the opposite of what you see. So we start plotting at the point 3 over 1, good. There's my first coordinate point, and I'm going to go from there up 2 over 1, up 2 over 1, up 2 over 1, until I feel really good that I can draw a straight line with my ruler. Please use your ruler. Please give me nice, accurate graphs. And voila, there's my graph. You know, I said I would let y'all try that one on your own. I did the whole thing. Oops. But you've got the rest of this paper. So you and your partners, or you and your brain, are going to do 3, 4, 5, and 6. Hold on. And when you're done, raise your hand. We'll give you your homework. We had people in our last class finish the homework before they even left today. So work diligently and you don't have any homework. That sounds great. Let's do that. I will put an answer key up on the board here in a second. But get started on